Hey everybody, we are going to look at some basic algebra review today. This one's going to mainly focus on one and two step equations. So hopefully by the end of this video you understand that when we're looking at equations like this, we have to focus on particular parts in a particular order. So I'm going to kind of walk through that and I'll give you a bunch of examples. So hopefully this will help. So the equation we're seeing in front of us is x plus 3 equals 4. Now the goal is to get x equals. We want to know what value of x makes this whole statement actually work. And you may say, well, that number is 1. 1 plus 3 makes 4, and that's correct. But to solve more complex equations, we follow a certain order. And so what we look at when we look at an equation, we want to find our variable. Our variable in this case is x, and then we want to know what's happening to it. Oftentimes, x will have numbers multiplied by it. Could be positive numbers, negative numbers, fractions even. And then usually we might also have in these equations some sort of number added or subtracted away from x. That number could also be 0, meaning that there is no number there per se. There's no value there. But in this case, we do have one. And so what we want to do first each time is look at the number that is not attached to x, but a number that's being added or subtracted from it. And in this case, it's a positive 3. In order to get rid of that, in order to get x by itself, we have to undo a positive 3. And what that means is we're going to subtract 3. But in order to solve for this correctly, we have to do that from both sides of the equation. Now, on the side with x, we have canceled this out, right? Positive 3 and negative 3 cancel, and that's by design. And we're just left with x. And the right side will be 4 minus 3, which is the number 1, which we came up with earlier. So again, if there's a number that's being added or subtracted away from x, we want to deal with it first. So we could do that if it's subtraction as well. Instead of subtracting 3 this time, because the value that's being taken against x is minus 3, we want to add 3 to both sides. This leaves us just with x equals 7, right? So just a little switch of positive addition and subtraction changes the overall solution to this problem. But again, we pick the same type of part of the equation and deal with it first. So it still works, right? It doesn't matter what's on the other side, right? Negative 4 could be any number on the other side. We still approach this the same way. We look for the side where there's x. There is 3 being added to it, so we're going to subtract 3 from both sides. And this is going to give us x equals negative 7. Now, again, this is negative 4 minus 3. You could also think of it as negative 4 plus negative 3, right? So when we add negatives together, we actually get bigger negatives, right? Or more magnitudus. I don't even know that's a word. Don't ask me about words. So that's kind of all the things you can see in that regard. We also might have multipliers on x. These are called coefficients. And so this time there is 2 x's. So we still proceed like we did in the last problem, but after the initial step, we'll still have one more to do. So if there's something attached to x, that's fine. Like a number like 2, or even if it's negative or a fraction, we'll deal with it. But the first thing we want to do, like in the other problems, is get rid of any number that's being added or subtracted away. So if we have a positive 4, we're going to subtract 4 from both sides. And this time, we will have 2x equals 10 minus 4, which is 6. Okay, now we're not done, right? Because we want to solve for x. So we look at the number that is being attached to x. In this case, it is 2 times, right? So if we do 2 times a number, in order to find out what that number is, we can divide both sides by 2, right? So if I divide both sides by 2, I'm going to get x equals 3, right? 2x divided by 2 is x. 6 divided by 2 is 3, right? So again, in this case, if we have 2 things happening, right? We have a multiplier on x and we're adding as well. We take care of the addition or subtraction first, then we deal with the multiplication later. Okay, so just never forget, we always get that one additional step there. 3x minus 6 equals 9, same idea. We're going to add 6 to both sides. This gives us 3x equals 9 plus 6 is 15. Right? So 3x equals 15. We're multiplying x by 3. So to undo that, we're going to divide both sides by 3. And we'll get x is equal to 15 over 3, which is just 5. Okay? So again, in this case, again, we're subtracting away from 3x, so we deal with it first. Then we take care of the division. All right? Remember, always we got to do that if there's a multiplier. So what about 4x minus 1 equals negative 9? Okay, so same idea, right? We've got a number times x. We have another number next to it, minus 1, and then that equals a negative number, right? So we're going to deal with the a subtraction first. We're going to add 1 to both sides, right? So this is going to become 4x. This side is canceled, is going to equal. Now, be careful sometimes with this, right? We see negative 9, and we're adding 1. Okay, so we're getting closer to 0. So negative 9 plus 1 is actually going to make negative 8. All right, a lot of mistakes will happen with this case. People will say negative 10, and that's negative 9 minus 1, right? We're going the other way. Adding 1, we got to kind of come back towards 0. Then we have 4x over negative 8, and we're going to divide both sides by 4 and get x equals negative 2, right? So if I know 8 over 4 is 2, negative 8 over 4 is negative 2, right? The negative just kind of rides along with it. So that's where we get our solution here. So what if we have negative 3x plus 1 equals negative 8? Again, this is kind of a scary equation, it looks like, right? Because we've got negatives all over the place. But again, we deal with it the same way, right? It doesn't matter that this is negative 3. We'll deal with it later. We want to deal with this positive 1 first, right? One step at a time. So we subtract 1 from both sides. We're going to get negative 3x is equal to negative 9, right? In this case, they do stack, right? Negative 8 minus 1 becomes negative 9. And then we see this negative up front, right? So a couple of things keep in mind, right? If both sides are negative, it's as if neither is, okay? Right, so we could drop the negatives at this point if we wanted to, but for the sake of being consistent, I'm just going to divide by negative 3, right? It doesn't matter if it's 2. If it's 2 times x, we divide by 2. If it's 4 times x, we divide by 4. If it's negative 3 times x, we divide by negative 3. And we'll get x equals negative 9 over negative 3. Now that's a double negative, right? Double negative means they cancel. So we just have 9/3, which is 3. Okay? So if it had been a positive 9 divided by negative 3, our answer would have been negative because it would just be one of the two parts of our quotient would be negative. But when we have both of them, they cancel each other out. How nice. And what if we have fractions, right? So again, a fraction is just like a multiplier. We think of it like we're dividing, but division and multiplication are kind of two sides of the same coin, right? So we treat it sort of the same way, just like we've been dealing with addition and subtraction, right? The addition and subtraction part goes first, right? And then the multiplication and division part kind of comes second. And we use the inverse operator, right? So like instead of, this says minus 1 here, so we're going to add 1, okay? Oops, sorry. We're going to add 1 to both sides. And this gives us x over 2, this cancels, equals 2, right? So we undo minus with a plus. We undo division with multiplication, right? So since we are dividing both sides by 2, I'm going to multiply both sides by 2, right? On the left side, 2 times x over 2 just makes x, right? That's by design, right? If I just undo whatever's happening to it, I'll just end up with x. And then we have 2 times 2, which makes 4, okay? All right, so just like the other problem, right? Deal with addition, subtraction first, then deal with any multiplier or divisor next. Right? So what if we have a negative and a fraction, right? So again, this is it's just stuff that we deal with in time. We don't need to worry about it yet. We deal with these two steps equations in a very specific way. I see this plus 2 here, so we're going to subtract it. Right? The goal is to get x by itself. In order to do that, we kind of, whatever's added or subtracted, we deal with it first. So we're going to get negative x over 3 equals 8, right? 10 minus 2 is 8. So now, not only are we dividing by 3, but it's also, we also have a negative sign, right? So we can actually deal with both of these at the same time. Imagine like this negative here kind of really means that we're also kind of dividing by negative 3. That may help some people. A negative out front means we could actually give it to the x or we could give it to the 3, just one or the other. I'm going to give it to the denominator just because you can see, like from the previous example, if we divide by negative 3, we could undo it by multiplying by negative 3. And so we should end up here with x equals, again, 3 times 8 is 24. But since it's negative, we get negative 24. Okay? So again, just like the other one, we do one step at a time, and that should lead us to our answer.